Let's now take a look at this problem that involves the comparison of two means under a before and after scenario, or where the individual data is paired. For the first step of this problem, well, let's set up the null and alternative hypotheses before we forget. The null hypothesis is going to be that the mean for the stop and go is going to be equal to the mean of the highway, whereas the alternative hypothesis is that the mean for the stop and go is greater than the mean for the highway, that the mean level of emissions is less for highway driving than for stop and go driving. The next step is to actually figure out the differences for these pairs. So we have this is equal to A1 minus A2, so I'll just simply take 1500 minus 941 to get the difference, 559. And then I repeat to get the other 8 differences. Now that I have these 8 differences, the numbers in rows 1 and 2 here do not matter. And so what I will do is just simply look at these 8 numbers here and proceed with the problem, just simply ignoring where they came from in the first place, now that I have these differences. Okay, so the mean difference, I take the average of these 8 differences, and I get 190.5. And if I take the standard deviation of these differences, I get 284.1. So the t-value in question here is going to equal the observed difference, 190.5, minus the expected difference under the null hypothesis, which is 0, divided by the standard error. Now, because this is paired data, I can just simply use 284.1 divided by the square root of 8. And so the t-value will be equal to 190.5 minus 0 divided by the standard deviation over the square root of n. So 1.897. I have 8 different cars that are being tested, and so I have 7 degrees of freedom. And so let's figure out the area, this time to the right of 1.897. So the p-value will be the area to the right. So the p-value will be equal to t.dis.rt of this number with 7 degrees of freedom, which gives us approximately 0.05, and if I get more places, 0.04986. These are the ones that give professional statisticians headaches, that we have a p-value that is so close to the cutoff. So we have a p-value that is 0.04986, so 0.0499. And so that is less than 0.05, and so our decision will be that we reject the null hypothesis. We have reason to think that emissions are lower for highway driving. Now, of course, we don't have terrific reason to think this. The number is less than 0.05, and so we make this decision. However, certainly the professional statistician would report that the exact value, the p-value, and then think about whether or not that is enough to cause a change in behavior of the company based on this sample.